Hey AP Calculus students, welcome back. Today we're doing U-Sub Part 2, 7.2. So for the first part, we're just going to use our trig identities to set up this U-Substitution that we have here. A lot of times if we use well, not a lot of times, but sometimes when we use our trig identities, it makes our antiderivatives a little bit easier to do, especially if we have stuff that we don't have formulas for on our cheat sheet. Okay, so let's do part A. So we're looking at the integral of, or antiderivative of dx over cosine squared 2x. So what we're going to do here to make it a little bit easier, we're going to change that. Remember, we have the reciprocal function 1 over cosine is secant. So we can rewrite this as secant squared 2x, and then our dx stays here. Okay, and this makes it easier because we do have a antiderivative for secant squared, but we don't necessarily have one for 1 over cosine squared. Okay, so remember, this is our inside. U is 2x, du is 2dx. So we need to rewrite this with our 2 there because of the chain rule, or the quotient, sorry, the U-sub, which is the reverse of the chain rule. So now we have our du here. And then we need to make sure we balance out that 2 with the 1/2 in front, right? So these two need to agree that needs to be 1 when we multiply. All right, so let's rewrite this in terms of u. So this is going to be u squared du. Or sorry, not u squared. It's going to be the integral of secant squared u du. So now we can do the integral, right? So with respect to u, we're going to do tangent u, right? The du is gone when we do our integral, and we're going to have a 1/2 in there. And then now we can plug back in our 2x for our u. So 1/2 tangent 2x plus c. And we'd be good. Okay, on to the next one, cotangent squared 3x dx. Now this one's a little bit more difficult. This one's a Pythagorean identity. So we're going to do this one as the cotangent squared is the same thing as 1 minus, is it 1 minus or cosecant minus? Cosecant minus, sorry. So this is going to be cosecant squared minus 1. Oops, sorry. Forgot to put our 3x in there. 3x minus 1 dx. Okay, so for this one, our u is a 3x. Then our du would be 3 dx. So let's rewrite this. So we have the integral of 3 cosecant squared 3x minus 1 dx. Actually, I think I want to put that 3 outside the parentheses. Not sure if it matters, but it looks better that way because then we have our 3 dx all together. We don't have to worry about pulling it out of the parentheses. And then we have to balance that 3 with the 1/3 outside. Okay, so what we're going to do here is we're going to rewrite this in terms of u. So 3 dx is our du. And then this part is going to be cosecant squared u minus 1. Okay, and then we can do our antiderivative. So the cosecant squared antiderivative is negative. So we'll put the 1/3 here. Negative cotangent u minus, remember the 1 when we do the antiderivative, that becomes a u. And then at this point we can substitute back in our u, so that would be 3x. So negative cotangent 3x minus 3x plus c. Now be very careful here. If we didn't do it in terms of u like we did, we might easily forget that when we do our minus 1 to the u, that this is still a 3x in there. We might just put an x, so just be aware, and you should be fine. Okay, and then on to part C. So this one's a little bit trickier still. So what we want to know here is that cosine squared x times cosine x is the same thing as cosine cubed x. Okay, so we're going to separate it into a cosine squared and a cosine. Now, we know that cosine squared from the Pythagorean identity is going to be the same thing as, 1 minus sine squared. Okay, so this thing becomes 1 minus sine squared x. That's a Pythagorean identity. Now, our u then, we're going to say is going to be our sine x. And our du is going to be cosine x dx, right? The derivative of sine is cosine. Okay, so let's rewrite this. This is going to be the integral of 1 minus, 1 minus u is sine squared du. Notice we don't have to balance anything out, right? Because the cosine x is the cosine x. This is exactly what we wanted to from the beginning. Now we're going to do the integral here. That's going to be u minus u cubed over 3 plus c. And then we just go ahead and plug back in our u. So that's going to be sine x minus sine cubed x over 3 plus c. And that's going to be it. So just more U-sub practice, a little bit more complex because we wanted to use our trig identities in order to make our antiderivatives a little bit easier to find. Okay, on to the next one. So this one, we know that the derivative of tangent is secant squared. So let's make tangent our u, and then du would be secant squared x dx. Okay, so pretty nice so far. We're going to set up our integral, but when we do our integral, because we're going to use u's and tangent is u, what we're going to have to do is we're going to have to substitute our start and end point into our u, so that we can have our new starting and ending points reflecting our u's from our function, right? So if I plug in 0 to tangent x, then I get 0. Right? Tangent of 0 is 0. Now if I plug in pi over 3 into tangent x, then that's a little bit trickier. Remember, tangent x is the y over the x, so then that would be square root 3 over 2 over 1/2. Now remember, anytime we have a complex fraction, we can multiply by the reciprocal of the denominator, which cleans up nicely. So this is going to be radical 3. So just be aware here that in this step, be sure to substitute the start and end into your u. In this case, u is tangent x, right? And then these two numbers here should reflect the new starting and ending point. Okay, from there we have u du already, so we're gonna have u is tangent x, du is secant squared x dx. So we're just gonna do the antiderivative here. The antiderivative of u is u squared over 2, and we're doing this from 0 to square root 3. So the reason why I said to reflect these things in terms of u is because it makes it easier at this point. We don't have to reconvert it and plug back in our tangent in order to solve. What we're just going to do here is we're going to do our square root of 3. Oh, sorry, before we do that, remember that when we're finding our definite integrals, right? Integrals where we have a start and an end point, we want to come out with a number. So to find that, we're just going to do capital F of b minus capital F of a. So we're going to take our b here, our ending point, which is square root of 3, squared over 2, and we're going to subtract the same thing from the starting point, so that's going to be 0 squared over 2. So the square root and the square cancel, that's 3 halves minus 0, which is 3 halves. So in doing this part where we substituted our start and end into the u's to make it reflect the u's, we don't have to go back and plug back in our tangents and then find our value that way, even though you can, and it'll be fine. This kind of just skips, it saves us some steps because now we just plug it directly into our u. It makes our life a little bit easier. Okay, one more example. Another definite integral, right? Because we have a start, which is 0, and an end, which is 1. So for this one, our u is going to be this bottom thing, x squared minus 4. Our du then would be 2x dx. Now notice we do have that x in the numerator, but we don't have the 2, so we're going to rewrite this to reflect that. We're going to do the integral from 0 to 1. Notice we didn't change the 0 and 1s yet because we're still in terms of x. We want this to be 2x, so we're going to say 2x times 1 over x squared minus 4 dx. And then in order to balance out that 2, we need to make sure we have that half out in front, right? So we're going to do that. Now we can rewrite this in terms of u, and when we do so, we're going to reflect that in our integral. So then our integral then, if I plugged in 0 into our u, that would be 0 squared minus 4, so that's going to be negative 4. The 1/2 outside doesn't change. And then when we plug in our 1 to our u, we get 1 squared is 1 minus 4, which is negative 3. Okay, now we know our integral is good in terms of u, so let's do the second part. 2x dx is our du. And then this is just going to be 1 over u. Alright, so the antiderivative of 1 over u is ln. You can find that on your cheat sheet at some point, I believe. 1 over u. Yeah, it's on the third column, second from the top. Okay, so this is going to be 1/2 ln absolute value u from negative 4 to 3. Okay, so let's rewrite this. This is 1/2. We're going to plug in, remember we're doing f of b minus f of a. So b is, this is negative 3. So this is going to be ln absolute value negative 3 minus ln absolute value negative 4. So the absolute value of negative 3 is 3. The absolute value of negative 4 is 4. And technically, I think you could leave it like this, but in the book, they go one extra step, and they're just using the properties of logs and saying anytime we have a subtraction with 2 logs, or logs at the same base, then we can say that that's going to be the ln of the 3 divided by the 4. and we'll be done. So hopefully this gave you kind of a little bit of insight to what the U-sub stuff looked like. Some of these are a little bit more difficult, but the more you do, the better you get, really. And then the more you train, your eyes are trained to see what the inside, the U would be, and then if there's a DU on the outside, or if we can manipulate it in any way to get a DU, then U-sub should be pretty easy for you. In fact, as you get better, you might even be able to skip some steps there. But yeah, good job.